Hi, folks. Today we have a special guest speaker, and I have to give you the intro. The reason he's here. A year ago at the big Computer-Human Interaction Conference, you gave me a demo that was a killer demo, and it was the predecessor system to this. And so I said, this is fantastic. We need to have this in our class. So here we are a year later. We finally managed to convince Ruofei to come over from Google. You've been there, what, 5 years now?
Yeah, 5 years.
And he works in the AR, VR group, but this is his passion, is teaching people how to build pipelines for AI systems.
What do those abbreviations, AR and VR, mean?
Great question. I'm going to turn it over to the expert to expand those acronyms. Go ahead.
Awesome. Yeah, thank you, Dan and Peter, for the great question and introduction. Good morning, everyone. Yeah, I'm so thrilled to be here today to share my latest research in visual blocks called ML, visual prototyping of AI pipelines. And prior to the talk, I would like to give a brief introduction of myself. My name is Ruofei, and I'm currently a research scientist at Google AR, where AR is short for augmented reality, where our mission is to give people the superpower to augment human abilities through blending the virtual with the physical world. You can find my profile in Google Research, and also my research can be broken down into 3 areas: human-computer interaction, computer graphics, and computer vision. And if you are interested, feel free to jump to my website to learn more. But today, our main topic is the visual blocks of ML. So in the past few years, real-time machine learning models have gained mainstream popularity, including 3D photos, portrait relighting, and virtual backgrounds. Almost everyone is using in remote meeting in Zoom and Google Meet. Despite of these real-time machine learning advances, the current generation of the machine learning pipeline still requires complex coding. For example, look at this relighting pipeline from fgraph 2021. It consists of a geometry net, an albedo net to infer the color of the object, and a shading net to learn the shading or the lighting shadows of the image. And each time, if you want to replace the image with a real-time webcam image input, or you want to replace one of the neural networks with another neural network, it takes a lot of coding effort. And also, it takes a long amount of time between communication from the UX researcher, the software engineers, and production manager. So we wonder, what if we could build AI pipelines? If we build Legos in our childhood? So out of the curiosity of this question, we dived down into the year-long research project called Visual Blocks. So our work is built upon prior art in AI King and prompt tuner by Michael and Carrie in Google. However, this focus on mostly language applications, where we focus on graphics and more visual things. And actually, the node graph editing is not a new concept. It dates back to almost 1966. And a lot of computer graphics engineers use the node graph editing to make immersive 3D applications. So with these advances of these models, we wonder, what if we can bridge the machine learning models together with vision, together with graphics, and today, together with language, to build useful applications for the world. And that includes a lot of off-the-shelf things like hand gesture detection, body segmentation, landmark detection, object recognition. And these are all readily available in Visual Blocks right now. So the major challenge is trying to bridge the gap from your idea to the end multimedia applications. So to start with this, we conducted a formative study by interviewing 7 machine learning practitioners in multimedia domain. And we start this actually with a sketch. And this is a common method of many HCI applications. We make a mock-up of our desired interface, and we interview people. What features would you like? What requirement would you imagine you could meet with this interface? And with this interview, it informs us 6 design goals. The first design goal, as we want people to be rapidly building AI pipelines with our system, and it should support real-time multimedia in the wild. And it should provide interactive data augmentation where users can change the brightness, contrast of the input to test how robust your model is. And fourth, you should be able to ask people to compare one model versus another model so that you can learn how the new model outperforms the former one. And fifth, we want people to be able to share the AI pipeline you made with the world easily. And finally, we want to provide people with a state-of-the-art, off-the-shelf model so everyone has equal access to the system. So here's a teaser demo. So this is back in days, our initial version of Visual Blocks, where you can do some body segmentation, shader processing. Yeah, no worries about speed. We will do a live demo step by step later. And it can also do like amazing like shader effects that you can create a new augmented reality camera effect directly in the browser. And more interestingly, like if you are a graphics person, you can even change the kernel background to make it blurry in different ways. And this demo quickly shows like how the data augmentation works. So you can add noise to the input, and you can compare like two models side by side. This is the image, and more amazingly, you can directly download the image and put it into the class report or your paper directly as a bigger legend. All right, so that's the interface of our system. So it consists of a node library, where we classify the nodes to roughly like 5 or 6 categories, which most importantly is the input node, like where your input should be coming from. For example, it could come from a camera input, an image input, a sketch, or language input. Or maybe you can convert your audio stream into the language. And with the input, like you also think about like the output you want. It could be a 3D player, it could be a bounding box visualizer, image comparison to have side-by-side comparison, image viewer, a landmark viewer, so that you can debug how robust your landmark detector is. And we provide a lot of all those, including like body landmarks, which identifies your left arm, your nose, your face. Body segmentation will segment out your foreground with your background image, and face detection with your on box and the landmark. We'll play with later. And by process, we mean like traditional image processing pipeline, including you have a bounding box, you want to an image, you have 2 images, mix them together, or you want to render them using a graphical shader, or you want to combine one text input with the other text input. Okay, the next part is a node graph editor, where the main editing process happens within Visual Blocks. So here's an example, like the MVP demo. For example, we first get an input from the text, where users can enter the text. And here is a search, and ask you to around the user. And for the image, you can your image editor to crop it to change the brightness, contrast of the image, so that you can be used for the neural network in later. And here's a breakdown of the inputs. And in the category, the list to control what option you want from the processor. And finally, go to the preview panel where you see the results of your machine learning pipeline. For example, here in the former pipeline, there our input is text, and we search it in the text image, and then you can change the brightness and the contrast so it can adapt to your interactive options. All right, so let us dive into some demos. For example, if you are, this one I will just show my laptop. The next one we can do it together. Let me click on one example. All right. Oh, by the way, so here I provide some like a Gemini key. Right now, like Gemini is open access to everyone. If you go to this link, my last name, firstname.com/vdkeys. You will be able to access a Google Doc where I shared some of the APIs for you for the class. It will be available to the end of the week, I think. And I gave like the instructions how you can access the keys later. And now you can copy the keys and go to the demo here, my website /vddemo1. If you want to edit it in your laptop, feel free. But this for I will go through visually in my laptop, and you don't have to follow this one. For example, I'm asking here, what is the weather like in San Francisco? And the input is a text input. And let me fetch. Oh, sorry. All right. So it gives a very long paragraph saying the weather in San Francisco is actually mild and comfortable. However, too long and I don't want to read. So I get another text input into summarize it into one sentence. This is a very basic chain of AIs where one AI will be responsible for getting the results from Google search, for example. The other AI is responsible for writing or turning it into another structure like in JSON or in bullet points. And here we use a text formatter. So it creates, it is a text input, sorry. It gets the text input of the summarized in one sentence, and the other text input from the first language model, where you can combine the summarization prompt together with the answer of the first model. And here, the API key. Yeah, boom. Now you can summarize it. Okay, San Francisco has a Mediterranean climate. It's warm, dry summer, and cool winters, which is correct. And next, let's come to the demo. Yeah. So this is like maybe people are already using it every day when in their class report writing, like generate awesome titles for the following paragraph. And I put the abstract of my paper last year into the demo. You can copy the API key, and let's see what's going on. Okay, great. So it says a visual programming platform, blah blah, and improving the prototyping of ML-based application or evaluating for real-world case studies. So it gives you a brainstorming of what potential title it could be for your class report or abstract. So how about something like more visual and graphical? So let me give you some more examples. This is a customized model where, okay, you can just change the input, and it gives you a stylization of the input image ad hoc in real time. And this model is from TensorFlow Hub, where you can download like hundreds of real-time available models and put the URL directly into the model. You can also upload your own TF-Lite model here. So this gives you an overview of the abilities of visual blocks. So the next one is, yeah, interactive data augmentation, where let me close down something here. Yeah, the first time when you are downloading the model, it may take a while because the system is downloading the model from the internet. Oops. All right, here we go. So here you can see like this is an object detector from MediaPipe. However, we want to see like how robust the model is. Let's do a very interesting experiment. Let's rotate. So 31. Okay, so there are two dogs here. Let me see. How about 72? Wow, here we go. There's something interesting like the model misrecognized the dog into a cat. So this is because like the rotation augmentation in your training set may not be as robust as you envisioned, and it may inform you, okay, how about in the next training time we add more images with rotating in weird angles.
Go ahead.
Go ahead.
Maybe cats lie on their side more than dogs.
Yeah. Oh, that's a very good observation.
Yeah. I mean, I was going to comment that the cat bounding box is way wrong.
Yeah.
Yes. It is very long, and it's because of also like for neural networks, there's something called like receptive fields, like what is the largest kernel of your convolutional layer is, and it may be like this layer looks like some cat in a weird shape.
Well, like Peter said, it's possibly seeing the top of the corgi and the side of the mutt as being part of the same cat.
Yeah.
Hence the bounding boxes like that.
Oh yeah, maybe. Yeah. Anyway, so this to give you a very intuitive visualization of how robust a model could be. And if you want to have some counterexamples of model before and after, you can use the image comparison. So I think these are two. Okay. Yeah. These two you can like zoom in. For example, you want to do some superimposition touch. You are doing some depth sensing. You can hover and zoom in and compare and download the image and put it in your class report.
Right.
Yeah, this is the cat. All right. Oh. All right. So these are like learning by examples. Next, I'd like people to follow me and let's create a new pipeline from scratch of a virtual background application in real time.
And if you don't have a laptop, become friends with someone who does, because this is almost impossible on your phone.
Yeah. Oh, sorry. And first of all, if you have a laptop, type visualblogs.withgoogle.com. And if you don't have a laptop, feel free to share with each other. Yeah. Is everyone good to go? Yeah, feel free to raise your hands if you have any issues with the system. And here is the website. And if you click on new product here, you are going to, zoom in so everyone can see my screen. All right. Yeah. First of all, let's grab image input nodes. You can drag from the nodes library from the left to the right. Here we go. Here the image input nodes where you can change the input image, and you can also click manage and upload from your local disk. And next, okay, let's make the input image as a girl, and let's get something called body segmentation, and see if the model can correctly segment out the girl. So to do that, you drag from the input nodes to the empty space, and there's in recommended part there's body segmentation. Yeah, has every.
So can you back up? When you're dragging that arc,
Yes.
where are you dragging it to?
Yeah, I'm dragging it to an empty space.
Just any empty
place. Yes. And you click on body segmentation. And this is because we don't have our output nodes yet, so there's no results showing out in the preview panel. And next, from the mask, you drag a line to the empty space. And in recommended, there's a mask visualizer. Here we go. Has everyone followed me or any questions? Okay, I'll go walk around and see if everyone is following me. Yeah. Any questions?
And if you have any problems, raise your hand. We'll come.
Yeah, sure. Yeah. Yeah. All right. Here we go. I think most people have captured all of the steps. All right. With a virtual background effect, let's get another image input as background. So here, how about we change the background into a zoo?
Wait. Quick question.
Yeah.
You just grabbed that sub network and you kind of zoomed it out. How did you do that?
You mean in here?
Before you did that.
Okay.
Pinton.
Yeah, I'm just dragging the input into the camera here.
Right.
Yeah.
But did that have the side effect of making the other sub network get smaller?
Oh. This one you can use force to zoom in, zoom out.
So you're using a pinch within the pane.
Yes.
So
Yes.
when you do pinch in the window, it doesn't change the window, it changes the pane.
Yes. This is by exporting. Yes. Yeah. Also, like I'm having a very large zoom value, so it's 200 zoom in factor. So trying to have everyone be clear of what I'm doing here. And All right, let's try to mix the input and output together. For example, if you drag a line here, there's something called image mixer. It makes your foreground with the background. All right, let me see. And you drag the image from the input to image 2 here. And if you follow correctly, you will see a scratched image here. This is because the aspect ratio of the two images are differently. But yeah, we can. Let me see if we can. Oops. Yeah, if you change the mask into destination over, it means the second image is overlaid onto the first image in the transparency channel. This is because, like with the mask visualizer, the background is segment top is transparency, and we are overlaying the graph background with the input image. And now you have like an initial virtual background pipeline. And to make it with real-time input, you just change the image input with your camera input. For example, you drag a camera input here, and you can see me in real time. And from the image output, you can drag it into the body segmentation. And you need to change again for the mask visualizer so that it visualizes correctly of the mask. And here we go. Yeah. So you can have the real-time virtual background feature as you was using your Google Meet and Zoom instantly. Yeah. Is everyone following me? Any questions?
I have a question. Another. How did you delete the other art from the lower image box?
Oh, how do I delete this one?
Yeah.
You just click and press the delete button, or there should be a context menu here, delete. Yeah. And by the way, so to create new nodes, right click and there's add node button. So we have been keep adding new features into the system. And there's also zoom to fit. You can add a new node. All right. If everyone is following me, we can do something even cooler. We still have some time. Let's try to add an AR speaker to my virtual camera. For example, with the image input. Let me see what else I can do. Yeah, if you go from the camera input, there is something called AR sticker. Oh, sorry. Yeah, that's too early. From the camera input, there's something called, if you go to models, there are the face landmarks. For example, if you want to stick something onto your face, you need a model called face landmarks. Let's see what it gives to us. And from the landmark, you can drag another node called AR sticker. All right, here it shows nothing because there is no sticker image. But if you can just put another image into the sticker image, and you can change the sticker image to here and here. And then you can see some image stick to your head in real time. Yeah, you can put it into your eyes or nose. Yeah. 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 Yeah, this is a little bit complicated to see the graph. It's getting more and more complex. I'll make sure if everyone is following that. Yeah, include the. Oh, you need to use your photo. And from the image, what is the arrow? Oh, feel free. You can run. You have to give up. Did you guys see the arrow? Oh, I see this. Maybe because now here we go. There's no arrow. And from landmark, we can drag another line. From here, it's nothing because there's no sticker image. So how about you check another image? And you drag from the image to sticker image. Oh, the business is automatically this node is connected to the image. Oh, can you put any food? Yeah, this is long. Yeah, no problem. Yeah. Yeah, if anyone has questions, feel free to raise your hands, and I can do a like helping you. All right. Oh, yeah, I think someone even on it. Like with, by the way, with the Animator, there's an option called like top text, mid text, bottom text, and where you can generate some interesting effects here. For example, in top text, you can see like hello world. Yeah, here we go. And you can also like get a text input, for example. Here's a text input. And yeah, for example, hello. If you click the node of the image maker of the text input, you can change the final visual effect instantly in the browser. And imagine you can also create some like language application with top text. All right. Maybe let's yeah, you can feel free to share the pipeline you have and download it so that you can import it later. But now I would like to do another step-by-step project with text input, for example, text. Right. Yeah. In the previous example, we see like how the image and graphics nodes is working. And this one, you can start with a text input. For example, tell me a joke. And about, you can grab another node called, for example, cat. And we want to combine the first text with the second text so that in the future, user can just change the text of the second keywords to grab the knowledge. And here in model, you go to, for example, the PALM generator. Yes, sorry. Yeah, here's the model. And if you want the key, you can copy the key from my website, my first name, last name.com/vbkeys. Yeah. Oh. Yeah. Yeah. And here we go. You press the key. Oh, sorry. First of all, we need to like combine the two inputs together. And in the processor, there is something called text formatter. The text formatter, by default, it joins two strings with each other. So this is a little bit complicated because it connects two nodes together with 1, 2. And with the text output, you go with the PALM generator. And here we go. Tell me a joke about cat. Okay, let's try. Here we go. Why did the cat fall asleep in the bathtub? Because it was in perfect spot. All right. Yeah, it's always code jokes. Oh. All right. Yeah, hopefully you have followed the instruction, but if not, like in the slides, there's a YouTube video where you can follow it after school. And I will just skip it for now. All right, let me give another brief lecture about our use case of Visual Blocks at Google. So during the pandemic, we use Visual Blocks to quantitatively evaluate and qualitatively evaluate the feedback of several machine learning models for production. And the first one is PortReject model, where the goal is to infer how far each pixel is from the image to the camera so that we can create a 3D person. And the second one is that we want to infer like the depth map of input image so that we can overlay some AI effects. And third one, we want to improve the virtual backgrounds in Google Meet so that we can have a better blending from the front image to the background image. And finally, we want to evaluate like an audio noise denoising model. For example, like which one is preferred in Meet scenarios or in a phone call. So to do this, we interviewed with 15 or 20 Googlers. I think I forgot the N number. I think 15 experts. And they did a background interview, a video tutorial, and then they asked the experts to stay with us and try to compare two models side by side. And finally, we discussed with our experts to learn how they are using ViroBlocks for learning insights.
Quick comment.
Sure.
Raps AI is.
Yeah, Ruofei is a code name of the ViroBlocks. Yeah, I forgot to take the
Search and substitute.
Yeah, sorry. Yeah, for every project, initially we have some code name, and then the product manager changed it to some formal name. It happens in every project. And here we go. And we also ask people to compare with their traditional working pipeline, which is usually in a notebook or Colab space. And we found that our system has control because users cannot use coding to change their workflow. However, it gives people more transparency and a collaboration atmosphere. For example, in the back days, you spend like 1 hour a day or two to make a pipeline in the Python notebook. And now you can just have a half a minute or a few minutes to get a virtual background pipeline in HCIAI4. And it also helps people to identify issues with their neural networks. For example, with the interactive data augmentation, people know then how they should change the model architecture. And they can also give people the superpower to see when their model fails. And more importantly, the ViroBlocks also gives people an intuition about what data augmentation operation is missing from their training pipeline, and or give people a awesome view. And it allows people to compare different parameters. And for example, in this one, we have like 5 different models, and you can see there's apparently like a flaw of the models on the left and a flaw of the model on the top. And these numbers or metrics, it's very hard to identify these problems because the numbers is the averaging of all the results of your test case. But for this input in the wild, oftentimes you still need to like visually to examine the results to see what was the error of this model, despite the numbers are similar. And actually, like all the evaluation quantitative results of 5 models were similar in the benchmark. And it also make the pipeline easy to distribute. For example, after you make the pipeline, you can click the share button and download the data graph file, or share the URL to your friends, and the other person can open it directly in the browser. Yeah. And all right, so that's a brief lecture. Next, let's have our interactive brainstorming. Let's try to envision with a very powerful AI pipeline maker. Imagine you have access not only to the available models of Google, but also to Hugging Face, to Midjourney, to OpenAI. What AI pipelines would you want to make? And for this survey, you can enter with your phone. You can scan the QR code, or you can in your laptop. You can enter my website /ED survey. And there are 3 essential questions we are asking you to brainstorm regarding language applications, brainstorm regarding vision applications, or real-time mapping applications. And let's have a quick 5 minutes surveys, and then we can ask people to talk about what they want to make. I'll play. Oh,
Relaxing music.
Yeah. Oh.
That's a lot like the 3-body problem.
Yeah. Sorry, I think I was doing the lecture recording, so I will not play the music.
Yeah.
Oh, yeah. Sorry. Here we go.
And I would encourage you to think broadly.
Yeah, think broadly.
Yeah.
And thinking about there are actually essential questions, but also there's a brainstorming box where you can just put anything around. Yeah, and in addition to all the software inputs, there are also hardware applications. For example, you can connect video blocks, your toys, make it talk.
I guess we should also point the survey is anonymous.
Yeah.
So he doesn't know who anybody is.
Yeah. Don't worry about your input. Oh, I think it's already 5 minutes.
It's pretty close.
I'll see like how much responses we got from the survey. Yeah, we have 9 responses so far. Yeah, let's have another 3 minutes. Oh, is there anyone who would like to share your idea, like what AI pipeline you make? Yeah, go ahead.
I'm learning how to play a new instrument, and I don't know how to position my hands often. So I would love if you could watch me and tell me, like, oh, your hand is positioned a little off, or like, oh, your elbow sideways.
Awesome. Yeah, it's a great application. And this are like real-time monitoring of webcam and the input of an image. And you want to prompt it might posture correct or not. And this is actually doable with zero block. Yeah, often speaking, like you have the multiple Gemini working right now, and we hope to have it ready by I/O time, which is around like May 10th. And after the multiple Gemini API access to everyone, you can directly make one and input a webcam animation code and prompt it with my posture correct, and you can have a binary hardware. Okay. Anyone else would like to talk about what you want to make? Yeah, okay, now 18 responses right now, and maybe I will normally talk about them. I think.
Do you want to share your idea?
Yeah. Yeah, you want to share your idea?
Sure. Yeah. I was thinking, we walk around like a museum or like art gallery. Everybody kind of crowds this little plaque. But like you could sort of walk around and maybe get that information automatically while sort of scanning some of the widely recognized art pieces, like see it better.
Yeah, I love this idea. And actually, it's very well with AI glasses. In the future, we have AI glasses, which is actually accessing all the view information. You can have the instant knowledge of the art in a gallery.
So I want to build on that idea. I think it's a great idea. So take that idea, instead of just echoing the piece of work that's there, show me other artists at the same time or related images. So show me another 2,000 pictures of water lilies, right?
I was thinking,
By different artists.
highly immersive.
Yeah. Right. So it's a great idea. Yeah.
Awesome.
And there's another suggestion over there.
Yeah. And yeah. Okay.
I think like one thing that I'm always thinking about is like trying to find inspiration from places, especially as a designer. So I would love like to be able to pull like different creative perspectives and then give me like kind of like a brief or a description of like what are trends right now and show examples.
Awesome. Yeah, this is like advanced AI powered trip advisor.
Yeah.
Yeah, I love it. All right. The last one, anyone else want to share? Yeah. All right. Oh, you go ahead.
Yeah, like if you're taking like webcam input,
Yeah.
we have like text little captions or what I'm saying.
Oh yeah. Yeah. This is a very interesting project. We actually worked for last year where we want to visualize the concept people are talking about. But what unfamiliar concepts people are talking about. For example, you are in a Japanese restaurant with your friend, and you are talking about sukiyaki, and with glasses and LLM, you can infer the unfamiliar concept of sukiyaki, and you take the picture directly in your glasses. Yes, this could be a very useful example. Or when you are talking about like you are having a Disneyland trip with your friends, and the glasses could instantly pull your Google Photos and share with your friends ad hoc in real time. All right, yeah, I will share the survey result with Dan later after the class. And let's go to the tech time. So think about your pipeline, and you may or may not fulfill all your requests. But let's for a 10 minutes exercise and go to Bureau block and play with it. And there's also like a more node I enabled for you where you add experimental one. And so here you have to more nodes I prepared for Stanford students. So they are not open access yet, but feel free to use experimental flag. And you can also visit my Google Doc to access to the keys to the search engine. And okay, it's your time for 10 minutes, and then I will do closing notes.
So it's visualblocks.with Google Doc / experimental equal one.
Or you can click the new project and add it to the URL and refresh. Yeah, it also works. Yeah.
Cool.
So I think everyone has the URL right now, so I can also do a live demo of what capabilities of VisualBlocks has interactively here. For example, new. Yeah, you don't have to follow me. You can start your own. Yeah. Oops. Yeah, here is experimental equals to 1. Yeah. Yeah. Here is like oops. It's landmarks. Oops. It's landmarks. Oh, this is warning boxes. Is it working? Oh, here it is. Oh. Okay. Yeah, here we go. For example, here are some like new nodes I provided for you. Here are text input, sunglasses with transparent background, you can turn it into an image using Google image search. But in the future, we are providing you with image gen. And imagine you have Midjourney or other OpenAI models that turns language into a picture. But right now, Google image search is your friend. And here we go. And just like the previous tutorial, you can have a visual landmark detector, and you can mount the glasses directly into your face. I think this is old. Yeah, I think if you use the eyes, it's more accurate. Yeah. You can change the size. Yeah.
Yeah, there you go.
Yeah, there we go. It's more 3D and that works. Yeah.
So in the Google image search node,
Yeah.
it always returns the image of the first hit.
Yes.
Okay.
Yeah. I was lazy, like we only implement the first one.
Right. Right.
But you can change the prompts, like you can add like 1, 2, 3 to make the results more diverse. Yeah. It actually changes the glasses.
That's nice. Yeah.
Yeah, that's a interesting hack.
So that's the advantage of having a pipeline, right?
Yes.
Is it's constantly live.
Yeah, it's constantly live, and you can change it ad hoc.
Right.
Yeah.
Right.
Yeah, there are a lot of things to explore, and I'll go around and see what I can. Or if you want to share, you can also raise your hand and ask me questions. Yeah, I thought people are trying to use the search engine nodes, and I can do a quick example of that. Yeah, I'll go to a new project, like search. Yeah, for example, you want to search about like news about cat, and there's a Google text search, and there's API key which I provided to you. Oh, here it is. Sorry. And the search engine ID I created last night. Yeah, you can fetch it. And this one returns a web page URL where the output should be a string picker. Yeah, this is a formal search where you can search the first item, last item. For example, let's get a news from a new scientist and see what's the news is talking about. And the output could be a markdown viewer. Oh, oops, this is the URL. And there's like URL to HTML, which I wrote. Let's see if it runs. And from the HTML, you go from a markdown viewer. All right, with the news about like what's the news? Always too long. And here comes the power of the machine learning. You can add another node, like summarize the news. Let's do another text. Summarize the news. And that goes to a text formatter. Oops. Yeah. Yeah, no worries. We have all the examples online. I will show you where to find them. So you don't have to worry about how to, yeah. And here we have the summarize the news, and it's like a whole web page. And let's do a one model where the API key is a formal one I have here. Yeah, this one should work. Yeah. Oops. Yeah. And here we go. Oh, is API valid? Oh. Interesting. Oh, there's the S. Thank you. No. Oh, that's the wrong one. Okay. Should I reject the change? Yeah. Sorry. Okay, here we go.
So you might want to go back and change it on your notes.
Yeah. Oh. Is there something wrong here? Okay, here it is. Okay, here are some news. Yeah, the news talks about domestic cat eats more than 1,000 species of animal. So it's quite trying to grab the news from the news article and summarize it in bullet points. Scientists have just figure out how cats work.
Could you show us how when you made a new text node, you create a new one?
Yeah.
I'm trying to figure out how to know what whatever.
Yeah. Let's create a new one and
Okay, so you're creating a new, right.
text note.
So now the different possibilities you can do are, right.
Yes.
Now, how do you know what's under each of those?
Good question. So theoretically, we should better design the recommended part so it gives people recommendation. But for now, it's
So for example, how did you get to the
pump.
Palm thing
Yeah, pump thing is like the
model?
Yeah, it's under model. It's a machine learning model.
Okay.
And processor is just combining two texts with each other.
Okay. So the gray, which usually indicates a non-selectable option, actually is selectable.
Yeah. Yeah, this is a bad design. Thank you for the hint. Yeah, I'll forward it to my team. Yeah. Thank you. But here, you can. Everything is selectable. Like,
so everything is selectable and shows all the possible options.
Yes. And there's a wild, like for example, code. You can even like write custom API and code editor. And in each node, there's like the info button where you can have the detail, like what's missing in each node.
And so for students who want to use this for their final project, is there a way that they can export these things and save them and share them with friends?
Yeah, here it is. You can export it. And we are also welcoming contributions to the thing. And if you click the community part, and here shows like all example pipelines.
Okay.
Where you can do color prompt, AR sticker, 3D photo, title generator, and if you go to the GitHub and upload a pipeline directly to our GitHub, it will be uploaded to the website by each.
So the trick is going to be getting the API keys.
The API key, I put the instruction like how to get them. Like it's from Makerspace AI Studio, and I think it should be free for students.
And getting a search engine ID key is okay too?
Yes, that requires you to create a Google Cloud account, but that's free for students, as far as I know. Yeah.
How do they identify themselves as students?
I think students get free credits for Google Cloud usage, like hundreds of dollars. Yeah. This part.
That was the trick.
Yeah.
That was the trick.
Yeah.
You log with your Stanford EDU account.
Yes. If anyone needs a API key or search engine key, you can also ping me personally. As long as you don't use it extensively, I can share mine with you. Yeah. Anyway.
Better yet, write to Carmen.
Yeah.
Carmen will aggregate them.
Yeah. Usually, like
she'll talk to.
Yeah. Usually for my students, I sponsor my students for all the ChatGPT or Google Gemini nodes. All right. Yeah. I think we have only like 7 minutes left. I want to brainstorming about the future of visual prototyping. The question is like, how could we turn ideas into reality in the future? So as you all have brainstormed just now, everyone contributed to the survey, like what pipelines you want to make. So we wonder, what if we could directly turn the idea into reality? So this comes from our latest project of the future pipe, led by my students from University of Tokyo. And we try to build visual programming pipelines with human instructions. So traditionally, as you all and right now, they are selecting nodes, we are aggregating pipeline, we are selecting the nodes, pipeline. But here, wonder what we just describe what pipeline we make. And boom, the AI instantly creates a pipeline for you. So, for example, I want to grab AI link from Google and summarize it with bullet points. Boom. So this is what results are expecting from the AI, where you go from an input text Google search, you get the news from a list of images, you try to summarize it from text generator, and finally you do it in Markdown. So this is not also free. If you ever use GPT or you ever use Gemini, you realize the limits of the AI is not capable of doing such tasks. So to break down things, so we designed this kind of pipeline where it's consists of a node selector. It's kind of like an AI agent to select what node you need for this pipeline. And then we have like an AI loop where we explain to AI examples of each node and what's the possibility of each node. And we see this information and ask AI to write the pseudo code at the draft of the pipeline. And after this node, we have a code interpreter. It is kind of a compiler that compiles the pseudocode and fix the errors, and then it generates a rough editing pipeline within the browser. So this is where we call like the future of the visual programming. Just to show the quick demo. For example, you want to generate a tree. For example, you want to create a tree planner using you based on destination, number of days, number of people, and it gives you a very quick view of this. You just fill in the rest of 2 3 days. It generates day 1, day 3, day 2, day 3 directly in the order, and you can prototype it in your blocks as well. Or grab the AI from Google and summarize it using LLM. And here we go. You can grab the AI news and summarize it. You can change the start of the news. This is the best part allowed. Or you can grab some graphics from Google Image Search, and it means what you want. You want a parent from graphics. Here we go. Or detect whether putting an image is paying attention or not. Yeah, this is a multimodal model which is not available to the public yet, but we hope to public later. Get the real-time input data from and identify whether the user is looking at the screen or not. All right. In conclusion, so today the visual process for ML basically aims to lower the barriers of developers and designers access the model, and it also powers the experiments of these years. And finally, we hope it facilitates collaboration by sharing your pipeline with classmates, sharing your pipeline with the world. All right. Our final mission is with the right tools, we hope everyone could unleash their inner creativity. Yeah, thank you, everyone. That's the end of my talk.
Very good.
Any questions are welcome.
So we're here for another 10, 15 minutes. So if you want to explore, you've got the expert here. Better to debug now than at home at night. Right?
Yes, feel free to raise your hands, and or you can also ask questions like, yeah, what's your immediate future of visual programming?
Yeah. So I have a question. So this is great, and I can see how you can save a month of an engineer's time.
Yes.
But it still seems like you got to be pretty technical. You got to really learn a lot to use this well. How much do you think that's true? And are you planning to change that in the future so that you'd be someone who's much less technical can be successful?
Yeah, good question. So there are like two concepts we are thinking in the future. One is learning by examples, or learning by demonstration, where we provide some templates. Like for example, so in search and language, there are lots of templates you can get started with templates. Second one, learning by language. For example, just like the input type we show, it's one input box, and we give you a template pipeline on the input box. And in the future, I wish it to be conversational. Like the plan may not be correct, and you interact with, have a conversation with the AI agent, so it can help you to define the pipeline. But that's something we haven't done yet. I hope that's the future.
Right. I'm going to ask another version of my question, which was, I create a node of some type, and I'm trying to figure out, can I build this function into the pipeline? So, for example, you showed me how I can summarize or I can extract from a search results page. I can imagine other functions that I can't even imagine yet. So there's a function in there that allows me to talk to the dead. How do I find functions like that, or how do I come to understand the space of what's possible with the blocks?
Yeah, this is a very good question. So far, like I wish last summer, like we have an intern who did a community page where we establish a community where everyone contributes, and we can classify these pipelines into different areas, and people can learn this like community-based distribution, so that can build a problem. So there's another thing like to explain, like if you want to advance the learning of real blocks, what if you want to offer a new node? This is something really new. Actually, all the information follow slides. You can add a nice nodes to real blocks right now, and you can click the download button, and you can upload a new node with GitHub, and we will incorporate instantly the nodes into the image, text, and also the things, and they quickly text with all that. And there's examples of the nodes we have. If you go to our GitHub, okay, this is like a very of tutorial. You can contribute new pipeline to the GitHub pipeline, contribute new nodes into the custom nodes, so that everyone else can use your nodes in the future. So it could also be one of the kind of projects. Make new nodes from, for example, you can grab model from Hugging Face and make a new node from Hugging Face. You can create your new model using teaching for machine, and you can put a new node your own model. That's also doable.
So remember Teachable Machine, we did that a couple of weeks ago, right? So you can actually
but this is a little bit more advanced. You need to actually write code and contribute to the GitHub. It's open source.
I have another question.
Sure.
One thing I see a lot as a designer is that a lot of cool new tools are developed come from what is technically feasible, but not really from the perspective of what is needed in the world or what are unmet problems. What do you recommend us young designers? What do you think how should we approach these problems and build products so that we meet actual needs and not just use cool new technology?
Yeah, this is a very good question. And I wish there could be a future where designers and technical people could work hand in hand. And a lot of the needs are actually should come from the design and the researchers to dig into the needs. If there's that's a build block example. Let's say actually build machine learning practitioner, and we find out, okay, some parts of the compare model build and share it with people. It takes a month for people to build a virtual background application on the model and show how the model improves. That's why we make it in every pandemic one-click shareable with other people without on-site meeting. And another example is we have a video campus project on the website where we actually interview people in regular competitions. What video do you want? Imagine you have an AR graphic in the future, and people tell us you want to recognize the menus with unfamiliar words. Or in a foreign country, I want to visualize all the dishes. Or in a friends chat, I want to share my photos from my album. So these all contribute to narrow down scope of what kind of pipeline is useful to humans. Because a generic, if you ask, if you want to visualize this sentence, it may visualize every sentence max. Which may not be useful to regular computation, but with specific data and specific needs, we can dig out into how people gauge computation using customized dictionary and visualization of the AI and diving into different rules may contribute to a better question. Yeah, but
I guess I'm just curious, like you have seen people are discussing now, learning from your interviews, people who are getting with it.
Yeah, good question. Frankly speaking, like actually the first time ever we introduced the system to students, and in so we only like engineers and experienced designers using it compare model. Like what I said, we have like 15 interviews to sit down with people and actually use it production level model to compare side by side. Last year we started 20 project managers, but they are not like experienced people, and try to identify whether the language-based instruction has not a better all the AI pipeline from scratch. We actually find it useful. It's actually for project managers. They don't want to drag and drop nodes because there are so many nodes and it's growing. And it's a language-based draft that we can easily have a draft pipeline in the parameters, and finally we can like learn together with the language agents, like what's possible with system. Yeah, so that's what I hope in the future is conversational based visual protocol. Any other questions? Yeah, go ahead.
So I think it's really, but I was thinking, how do you actually integrate like a multi and results on like other platforms, right? Like it's right now, it feels like it's very kind of like calculated, locked into their own page. Like you know, have your camera up here on the website.
Yeah.
How would you use visual blocks for ML if you like, let's say, another website, another product, in a way that's like streamlined?
I think for the web, right now, you can export it as a JSON file, and yeah, this is a very good question. So we are also thinking towards the future how we can integrate into the story of Android platform. But right now it's a web platform and it's open access to everyone. You can even get external TensorFlow model through the system with the customized and the customized models. But in the future, because the AI pipeline is just a graph, it can download it and have it into native like Apple phones or Android phones. Yeah, thank you. Any other questions?
Right. I'm going to declare success. Thanks again.
Yeah. Thank you, Dan. Thank you, Peter.
So